going to show you in this video how to draw Lewis structure of a covalent bond compound, other word molecular compound. So when two atoms are bond together, you can either have a single covalent bond, a double, or triple. So it's pretty much look like one dash, that's one pair of electron, or two dash, that means two pair of electron, or three pair of electron, so forth, so on. Now, how do we know how many of these dash and dots do we put? Here's how you do it. So let's say you have CH4 compound, and you have C2H, let's say 6 compound, and you have a C2H4 compound, and C3H, oops, sorry, let's say C2 still. Let's stick with C2. All of these compounds are having the elements carbon bonding with hydrogen. So how do we even begin? Oh, we start with looking at the periodic table. So let's say C is over here and H is over here. Well, each of these groups, check out the video I have about valence electron, have certain number of valent electron, I mean the electron in the outer shells, that is available for sharing, right, or giving. Well, an easy way of remember it is the HONC group. HONC, H-O-N-C, means the H can have one valence electron, O can have H usually have one bond, O have two, and have three, and C have four. Oh, this is a biologist way to remember it. Anyway, so C here have 4 valence electron and usually form 4 bonds. So you got C having 1, 2, 3, 4 electron. Okay, and then H4, this little number means that there's 4 of whatever in front of it, so you have 4H. So I'm going to do it. So I'm just in the process of drawing 4H here. Okay, each of these H, remember H is 1, so each of these H have 1 electron. I'm going to write it over here. Okay, so what's going to happen is that both C and H going to want to be like a noble gas configuration. So it's going to want to be just like the noble gas that is on its row. So let's look at it. So H is right here. Yeah. So H gonna want to have the outer shell of helium, He here, meaning it's gonna want to have two electron. C is right here. So it's gonna want to be like neon here. And if you zoom in, C. Okay, neon over here, as you can see, it's have a 8, 2 on the inside and 8 on the outside. So 8 electron on the outside. So carbon is going to want to have 8 electron on the outside like neon. So in order for H and C to both get what they want, they are going to share these 2 electrons. So when you see a dash, that means 2 electrons. These 2 electrons are being shared, these 2 are being shared, these 2 are being shared, and these 2 are being shared. So C have 1, 2, 3, 4, 5, 6, 7, 8. Happy. This H can have 1, 2. Happy. This H have 1, 2. So forth and so on. Okay. Now same thing with down here. So you have 2C and 6H. How do we draw it? So by now you probably figure out that you want to put the atoms that have more bond in the middle and the guys with the less number of bond on the outside. So again, C can have 4 bonds. So you're going to go C1, 2, 3, 4. You see have 1, 2, 3, and then the fourth one is again the same bond with the other C. In each of these H, like we talked about before, can have 1 bond, so that's good. Okay, well, what about this one? Well, same deal. So this time you have 2C, but you only have 4H. So how do we solve this problem of C having 4 bond? Oh, got to get a little creative here. So you got 1 bond with H, 2 bond with H. This guy got 2 bonds, same thing. As usual, you got C and C bonding, but now you only have 1, 2, 3. So that's when the double bond come in. Well, I can't put a double bond here because H can only have 1. So the only logical place to put it is right in the middle. So this C and this C are now bond to each other by a double bond.
You know that's a whole.
So for the last example here, we have 2 carbon, and this time you only have 2 hydrogen instead of 4 hydrogen. So I'm going to write 2 hydrogen on both sides here, and you probably might have guessed it. You're going to have to use triple bond here because the C is sharing 1 bond with this H, the C having 1 bond with this H. Now the C needs 3 more bonds because it just have 1. So I'm going to say 1, 2, and 3. So there you have it. That's how you draw a Lewis structure.